Hey QED coders, this is Michael. We are continuing our deep dive into Jinaga modeling, historical modeling using Jinaga in Polyglot notebooks. So today we are going to talk about joining two different models together in order to create composite models, and hopefully we'll be able to get to the operational notebooks as well. So let's dive into that. If you'd like to join us every week on YouTube or on Discord, check out immutablearchitecture.com for those links. All right. So going to a quick screen share where we will be for the remainder of the session. Whoop. Oh, that's right. Yeah, I'm not doing the screen share live because Jan, oh no, Jan will not be joining us today. There we go. But if we do get folks, oh, that was the one I wanted to do all along. If we do get folks joining online, then we'll switch modes. All right. So the last time we talked, we went over creating mutable properties using the mutable property pattern, and that rounds out the basic modeling techniques that you're going to use. So just to recap, we're going to create a particular structure. Here we are inside of the scenarios folder. Let's go back to Jinaga.net, click on docs, go down to modeling, and this is all the things you need to install in order to follow along with these exercises. And then when you go to setting up your notebook, this describes the structure that we're looking at. So we've created a model, we've created a scenario, we've defined packages, and we've created a client and organized them in this way. And so client refers to packages, the model refers to packages, but the scenario refers to both the model and the client. And that's what we see here. The scenario refers to both the model and the client in that particular order. That allows me to define my model and then simulate some scenarios. See how querying the model works. Now, before we move on to some more advanced modeling techniques, I do want to show you a new feature in Jinaga.net. And that new feature is that we can take some of these facts, some of these queries, some of these sub-specifications, and we can move them into the facts. So there's an existing feature that will take care of this one right here. So let's suppose that I want this condition that the venue is not deleted. And you know what? That really should just be part of the venue. So let me come up here and let's define a condition. Well, this is going to be a public condition is deleted, and then using the arrow, I want to define this property as condition.define. And then I define this condition with a lambda, and we can see the shape of the lambda here. It takes a fact repository and it returns a boolean, being a condition. So facts is my fact repository, and then from there I can have this condition. So is deleted means that there is a venue delete, where the delete venue is equal to, well, now we don't have venue, we're talking about this. There we go. So that defines a condition. And now having that condition, I can use that. Let me go ahead and run all of these so that I get that new stuff in here. I can use that right here and not venue dot is deleted. Okay. Let's do the run all, make sure that this works. Venue does not contain a definition for is deleted. Is deleted is a condition. I've defined it. Expected. Right. There we go. If you define everything correctly, then you can now, let me save that. You can now use that condition, and you get the desired behavior. So here we've got the Bronco Bowl is deleted, and the American Airlines Center is the only one that remains. Good. So it's deleted is working. Now, so that was an existing feature, but what I wanted to do was expand that. I wanted to do the same thing with relations. So let's define these relations. So I'm looking for the name facts of a venue where there are not any prior names. So let's come back up here. Let's do public relation names. Relation.define. And just as before, we take facts as our parameter, but this time it returns an iQueryable of t. So let's use all my tools to create that iQueryable. So I'm going to do facts of type, and I'm going to talk about venue name, and then this is going to be the condition of that venue name. So name.venue equals this. So why is it not happy with this? Venue is there. Equals cannot be applied to venue and venue. Interesting. Okay, so whenever you see this kind of thing happen with Polyglot notebooks, it means that it's got two versions of the same type loaded, and it's having trouble with those two versions. So we will fix that with a reload. But that's not the only condition for the venue, and there are not facts any. Nay, I almost typed it again. Venue name next, such that next.prior contains name. So let me hit run all, see if that clears it up. Nope, that did not clear it up. Restarting will probably clear this up. And it did. Okay. So now the next thing that we ran into, this is this is an interesting part of Polyglot notebooks. This section right here defines its own little compilation unit. Venue name is outside of that compilation unit, so you can't forward reference a fact defined in another compilation unit, which is a bit unfortunate, but we will compensate by bringing the venue name into this compilation unit and including that in the render here. And now I can delete this one, and we've got this. So now the next thing is that it's trying to convert relation venue name to relation. So we need to know what the type of that relation is. So now I've got it. So we can use this to define a relation inside the fact itself. This is very similar to what you might set up with Entity Framework's navigation properties. So think about it the same way. So on the many side, you would define a relation. On the one side, you would define a predecessor. Venue 1, names many. So now that we have that, so let's save that. Come over here. Now here, instead of defining that that whole condition here, I can just say venue.names and then .select name hello name.value right there. And when I run all of those, now I've got that that names relation. So that's a new feature just added to the latest version of Jinaga.net. So you'll find that in 0.12.1, and it's a nice quality of life improvement. Okay, so we've got conditions, we've got relations. Let's move on now to more advanced modeling techniques. So I'm going to save this. So let's use relations. Let's commit that. Now I have prepared a couple of things ahead of time. So let me do a git pull rebase. And that pulls down a couple of new notebooks for me. Let's take a look at what we've got. Okay, so before we had venues, I have now added acts. So acts are the artists that are going to be performing at an event. And so we've got the act, we've got the venue. We're going to bring those together and we're going to create shows. So it's using all of the same properties that we talked about before. So we've got, you can change the act's title, you can change the act's image, you can delete, you can restore. Those are all there. And now I am going to create a model that brings these two things together. So let's create a new polyglot notebook, IPYNB C#, and then I want to bring these two models together. So let me import from, go out a level, and then one-models / venues.ipynb, and then we're going to import, go back out, one/models acts ipynb. Save it right here. This is going to be called shows. And now we can bring in both of those models. And so it runs both of those notebooks. Sometimes it gets stuck like this. So try to stop execution. Sometimes that doesn't work. Try to restart the kernel. Sometimes that clears it up. Yep, that seemed to have cleared it up this time. And so now we see the documentation for venues and for acts. So it runs those notebooks, outputs the result. We see the documentation. On the downside, that means I have some scrolling to do, but on the upside, I've got the graphs that I can refer back to. So now that we've got these two models, I can talk about shows. A show occurs at a venue with an act. That's an act performing at a venue at a particular date and time. So that's what it means to be a show. So let's not markdown, let's code that up. Let's talk about the fact type of Festify show. So this is going to be a public record, as all facts are. And it's going to refer back to now two predecessors. It's going to be the act, it's going to be the venue, then it's going to be the date, time, start. let's start with that. Let's now render types dot or renderer dot render types type of show with no semicolon, so that we output the graph. And you can see that a show has an act and a venue, both belonging to an environment, and that joins them all back up again. So that is what we are going to call a show. Now, what can you do with a show? Let's refer back to, let's see, I think yeah. I think I might have closed my mural, but this was the graph that we were working from. So remember here with when you're editing an act, you can then, or when you're looking at the act details, you can then create shows, you can delete shows. And that's all you can do with shows. You cannot modify their properties. So let's go ahead and add the show delete. So what are their properties? So we've got the venue. You started from the act, so the act and the venue, and then the start time. So we've already captured all of the properties of the show inside of the fact, which means they're immutable. That is the show. The show is the event that happens at that venue, at that time and date, and it's going to be that act performing. There is no other show like it. That's all that it takes to make a show unique. So now I'm going to make it possible to delete. Let's see how much Copilot can help here. There we go. So it can delete a show. Now, in order to support the restore, I want to differentiate one delete from another. And then that will allow me to restore the deletion. So delete show. So that way, if I restore a delete, but then I want to delete it again, I can create another delete show because it's distinguished from the first one by the delete at. And so with this, I can now show the full graph of what you can do with a show. Very nice. So this is an advanced modeling technique where you take different components of your model, document them independently, and then you can join them together. And using imports, you can organize your notebooks to keep them nice and clean. Let's save that off. So there's my shows model. Okay, so now what I might go and do is to go back to scenarios, and I might document a few scenarios of creating acts and creating venues, and then defining shows. What would happen if I delete? If I restore? If I delete again? What would happen if I delete an act or delete a venue? How would I write those queries in order to remove shows of deleted acts from a list, for example? All of that we could write scenarios for, but there wouldn't be any new patterns to demonstrate there. So instead, I'm going to move ahead to operations. This is a really powerful modeling technique. In fact, it goes beyond modeling. This is actually running your system using operational notebooks. It is a really cool capability, a really cool technique. So this is going to start right here with the connection notebook. So let me bring up the documentation for the structure that we're building. So we've got a connection notebook inside of our operations folder, and this connection notebook is the thing that that the various runbooks refer to back to. And actually, I think I'm missing an arrow here. Connection should refer back to packages, as we see here. So we import the Jinaga packages, and we make those available so that we can create a connection. A connection is very similar to the client IPYNB. Let's open that one up. And we can see that imports packages, and it sets up a Jinaga client. This one's using Jinaga test and a fake user, while this one is using Jinaga client. And so this is all of the capabilities of the runtime Jinaga client, including setting up an HTTP endpoint and an authentication provider. That's going to be important because we're going to connect to our real Jinaga replicator. Okay, so to begin, I've set up some code that will define a configuration file, and then it will load that from configuration.json. So this is going to have a property called environment, and then a dictionary of dictionaries called settings. Here's an example. Property called environment, a dictionary of dictionaries called settings. So the idea here is that I can switch my environment, and then I can keep different configuration values inside of the settings object with the same name. So I can do all of my local testing and set up a Jinaga endpoint and a token, and then I can switch to my test environment. And that will be a different endpoint and a different token, and I can flip back and forth by changing that environment. So that's the idea there. Now, I don't want to make those changes inside of configuration example. I want to copy this and paste it to configuration.json. And so that's that configuration. Let's go back here and undo the changes that I made to configuration example. Now I've got configuration.json all set up and ready for me to use. So if you'll notice when I come in here, configuration.json doesn't show up. Looking here, it's grayed out. So that's because configuration.json is in my ignore file. So this way, each individual developer can set up their own configuration, and then they can each load those into the connection IPYNB. That's important not just to keep developers isolated from one another, but also because here you're going to have a bearer token, and that's a secret. So, as a developer, I want to set up this this configuration. So, what am I going to do? I am going to come over here to app.jinaga.com. I am going to get logged in using my Microsoft account. Used to be using my GitHub account. Now it's your Microsoft account because coming very soon, this is going to be connected to the Azure Marketplace. All right, so I wonder if I might be having some operational issues here. app.jinaga.com. All right, well, there might be something for me to diagnose there. Well, it's not quite live yet. I'm actively working on deploying new versions of the portal, so that might be what's happening. We will continue on without the portal there. So that's what we would do is we would set up our replicator and provide the endpoint here. And then this, this code here will be able to pull the Jinaga endpoint out of that configuration for the selected environment and then use that to create our Jinaga client. Similarly, it will pull the token and use that as the bearer token authentication handler. So if we've got a token, we set that up. And then we perform the login, and now we've got our user and our profile. So this part we are not going to be able to show today. I will come back and show that at some point in the future, but let's now use that connection to do some operations. So what I want to do is to provision a new environment. So let's create a new blank notebook. This is going to bring in, we want to, I always get that backwards. We want to bring in two things in order to provision a notebook. So we want to bring in the model, and we want to bring in the connection. So let's go back to models, and this is going to be, so let's bring in shows, IPYNB. So shows is going to bring in all of the things. So let's bring them all in, and then import. We're going to import the 3-operations connection.ipynb. So that we will save as provision.ipynb. So that's how we will provision things. Now at this point, it's going to bring in, so it's going to show me the documentation for the shows. That's all of that. But then it's going to try to run the connection. Actually, it gave me a Jinaga client. If I, at this point, try to use that Jinaga client, it's going to have issues because it's connected to localhost 8000/Jinaga, and I don't have that currently running. But if I did run my own local replicator, I would be connected to it now. So these operational notebooks are good for even setting up your local environment. Now, the next thing that I want to do is I want to set up this environment fact. So let's see what it takes to create an environment. So I'm going to say environment. If I were to say await Jinaga client dot fact new environment. Not sure why it's not giving me IntelliSense for the Jinaga fact, but with the environment we're seeing all it takes is an environment name. So this is going to be my development environment. So if I try to run this, yeah, so it clears up the IntelliSense thing, but I can't make a connection to localhost 8000 because it's not running right now. But you can see that's what it's trying to do. So this would create a fact in my local replicator with that detail. But here's the problem. I want to secure these things at some point, and when I start to write my my security rules, I'm going to find that there's a problem. I need to limit who can create certain facts inside of this environment. And I can't do that if this environment doesn't have a user as a predecessor. So we have to have some user that kicks things off that lets us define those authorization rules. by the way, the new book is out. So this is the Art of Immutable Architecture 2nd edition, and in here you will find a new set of patterns. So in Chapter 7, we talk about the various patterns, like the mutable property pattern that we discussed, but one of those patterns is called Enterprise Domain. And this pattern, am I showing you the right page? Yeah, I think I am. Yeah, this pattern will, you're probably seeing it reverse because you're just seeing my feet reflected back. This pattern defines how you would set up an enterprise system that has multiple environments and set the security rules, authorization distribution rules for that domain. And so this that pattern kind of spells out what we're about to go over here. So we need to take this environment and put it under the control of a particular user. So in order to do that, let's go back to the act and the venue models, and we'll see that we've done a copy pasta. We've copied the environment type into both of those models. And that's not really what we want to do. We're going to continue to model our environment. So let's define a polyglot notebook and call it models environment, IPYNB. Okay, so being a model notebook, this has to import the packages. It's not going to use any other models, so we need to import packages directly. So we go out, go back to 0 setup, and packages dot IPYNB. So there's our packages. And now we are going to define the actual environment. Let's start with the environment that we had here, right? But now we want to modify things a bit. Let's do renderer dot render types, type of environment, without the semicolon. And that's all we've got so far. But we need it to have some kind of user that created the environment. So we'll say user creator, and that is an environment that we can secure. So now we can point back to that user and say, that's the user that is allowed to create things, to create facts in this environment. So that's one user, just one user. What is the, the sixth fallacy of distributed computing? It's somewhere down there on the list. The fallacy is there is one administrator. Here we are falling into that fallacy right off the bat. Nope, let's allow for multiple administrators. So let's create a fact type that is a Festify administrator. And so this is going to be a record that says that a particular user is authorized to administer a particular environment. And we will have a time at which we created that administrator record. And that's because I want to be able to revoke administrators. So let's go for administrator.revoke. We'll call it revoke administrator. So we want to revoke that particular administrator, and then we don't need a date time to distinguish that from other revocations. It's the revocation of that particular administrator record. We can always create another one for that same user if we decide to undo that operation. So this is setting up those administrators of the environment. Let's go ahead and add those here and see what our graph looks like now. This is a very familiar graph. When you when you start to get into operations, you're going to see this graph an awful lot. So what's happening here? We've got one user that is the creator of the environment, and then a different user that creator assigns as an administrator. And now you've got the capability of a user assigning additional administrators. So all that's good, and the user can revoke administrator privileges. That's good too. There's the question of, can an administrator revoke their own privilege, and can administrators revoke each other to the point that you have no more administrators left? Those are very good questions. The model does not prevent those things, so be cautious. But this is the starting point for being able to set that all up. Now, there is one other issue here. This creator is a special user. There is no revocation for that capability, because that's a predecessor. All these other administrators are through this successor relationship. So successors can come and go. Well, you can add new successors, and then you can add successors of those successors and change the effect. But predecessors are immutable. So you cannot revoke a predecessor. I've tried various techniques, like having a successor here that says that the creator has rescinded their own privileges. The problem is that you don't learn about that until later, and by that time you might have already accepted other facts that the creator has done, and it gets kind of wonky. So this is the really the best that you can do. But we don't want a human to be special. We want the special creator to be something non-human. Why is that? As you stand up this environment, that person, that initial administrator, might leave the organization after they've invited other administrators. You want to be able to revoke their privileges and then keep on inviting new administrators and just kind of roll through them. So this model does not allow for that if this this initial creator is a human. Fortunately, we can set this up so that creator is not a human, but instead a single-use principal. So let's go back to my provision, and now instead of creating a fact like this, when I do the run all, in fact, you know what? I don't need all of the model. Oh, yeah, one other thing. Yeah, I'm still using here this version of the environment, and here this version of the environment. So instead, I want to go back to I don't need to refer to packages directly anymore, because I'm now referring to another model which brings in packages. So models environment dot ipynb environment. Yep. So run that just to make sure. And let's see. Now run it. I'm expecting to see some output. I'm expecting to see this graph. Why am I not seeing that graph? Run all. I might need to restart my my notebooks. Let me hit restart on that just to make sure. Run all. Yeah, still not seeing it. Then I'm going to go to acts, and I'm going to do the same thing here. Yeah, I'm not actually getting the syntax highlighting on that one either. Okay. File does not exist. Environment. Okay. That might be part of the problem, but still that doesn't explain the lack of IntelliSense and the lack of error message. So, restarting the whole developer window. Okay, so venue. Now I bring in my environment, and I can use my environment in order to set up the venue. And now I can see that a venue belongs to an environment which has a creator. So the user is stuck there on the top. That allows everything to be authorized. With the acts, I should get the same structure. Very good. All right. Yeah, let's do that later. So now we have the environment set up for both acts and venues. So when I go back to my operational notebook and I try to provision things, let's close all the others. Now I don't need to import shows. I can just go back to environment. That's the only thing that I'm trying to set up. So let's run that. And now this is no longer valid. An environment does not just take a string identifier. An environment requires a user. So what user am I going to use? So in fact, just to make this work for right now, I'm going to go back to not connection IPYMB, which is what I would want to use, but instead I'm going to import from 0-setup / client.ipynb, just so I have a Jinaga client, but I'm not going to run into errors when I try to use it. So pretend I didn't do that, and that instead I'm actually connecting to the replicator. So now I need a user to provide here. Well, one thing that I could do is I say user profile, is I could say, await Jinaga client.login. And then this new environment could belong to that user. So let's Jinaga client.render facts. And so I want to render the environment. No semicolon, and then I get my graph. So there's the fake user that is logged into this test Jinaga client. If I was hitting the real replicator, that would be a real public key that that's associated with the bearer token that I configured. But you can see now I've got this situation in which this user is special. It's me. It's the first person who set up this environment. And I might leave the organization and somebody might take over that responsibility. You want to be able to revoke my access. Can't do that when you set it up like this. So instead of doing it like this, what I'm going to do is I'm going to wait Jinaga client dot, and then we've got single use. So this is going to be a single use principal. And now everything that I do inside of this lambda, so you see the user principal is coming in there, everything that I do inside of this lambda is going to be from the perspective of that principal. So I'm going to take this this code here, and now instead of the user being the creator, the principal will be the creator. Okay, so now I if I try to run this, there's going to be a problem. First of all, it can't infer what it's going to return. Single use always returns something. That's its purpose. But you can see right here what we intend to do is to return the environment. So doing things that way, now you can see the single-use principle has an actual public key. In fact, let's show that to you. Environment.creator.public key, and there we go. So we have a public key that was generated specifically for that single-use principle. Let's take a look at a certain part of it, like OYW or 0YW, and when I run it again, that's different. So I get a different single-use principle every time I run this. It's single use. So what does that buy me? Well, since I'm still here and I'm acting on behalf of that single-use principle, what I can do is make myself an administrator. So I want fact new administrator for this environment. Well, I put user first. User for this environment, and then the date, time, UTC now. Okay, so I do that, and now it has created this administrator for this environment. Don't believe me? Well, let me show you. So I'm going to go ahead and return the administrator. And let's do the Jinaga client dot render facts that administrator. Now you can see, there we go. This is the fact instance diagram that refers to that. It's similar to that same fact type diagram that we saw earlier. So this Jinaga user right here, this was our single use principle, was the creator of the development environment. And then this Jinaga user here is me logged in. But since I'm using the test client, that's a fake user. And then this fake user has administrator privileges to this environment. So now I can write an authorization rule that says who is allowed to create these administrator facts. And there will be two rules for administrator facts. One of them will be the environment creator. So that Jinaga user will be able to create these administrator facts. The other one will be that other administrators of this environment will be able to create these administrator facts. So after this Festify administrator is created, now I can invite other administrators to join the party. And then once I've invited all of them, then they can revoke my privileges. I can move on, and this Jinaga user is not me. It's somebody else. So who is it exactly? So that question has meaning in the security rules of Jinaga, of historical modeling in general, and that is who that is whoever controls the private key. That's who that is. So in the case of this user fact here, I have a token, so I have authenticated. I'm using a key store that is on the replicator itself. So I authenticate with that replicator, and now that bearer token gives me permission to use that private key stored in that key store. It never leaves that replicator. So that's just a bearer token for the replicator to say, okay, I'm going to sign all the facts using this private key. But I'm in control of that private key. It's just stored in that key store. The private key for this Jinaga user here, this single use principle, exists while I'm inside of this Lambda and then is discarded when it returns. So that single-use principal is this Lambda. Nobody else has control of that private key. It is never stored and never leaves the system. By the time you get here, it's gone. So that is the power of the single-use principal. That lets you create that environment and then invite your first administrator to that environment. From then on, administrators can take over, do what they need to do. And so that kind of plays back into, well, what happens if you lock out all the administrators? Well, you've already lost the private key. You can't invite anybody else. So yeah, be careful not to do that. Actually, there is a way that you can get inside of the Jinaga database, and you can kind of convince it to do the right thing. And that all has to do with the fact that these administrators and their revocations are not causally related to one another. So you can kind of rewind time and say, imagine that I'm still authorized, and this is what I did back then. So there is a way, but still be careful not to get into that situation. All right, so this is how you might use a notebook in order to set up a brand new environment. So going back over it again, we had our configuration file that chose the environment and then loaded the settings for that environment. And so we set up those settings here and then created our actual Jinaga connection to that replicator. And now we can use this connection in order to perform operations that we would really only do one time. There's no need to build a user interface for these operations if you're just going to be doing them once. So this is an operational runbook. It's something that you can use to to say, all right, let's set up the QA environment. Great, okay, let's set up the UAT environment. Another great thing about this pattern is that these environments here are independent of the infrastructure, of the actual hardware that's running these things. So you can actually set up a test environment inside of your production replicator. You can use that same hardware, set up a different environment, and test in production, and have the confidence that all of the facts that you create under the test environment will refer back to that test environment, and so therefore will not show up in production. So model your system accordingly, and then since you always have to have some starting point, that environment tends to be the starting point. It's the most natural thing for you to create a multi-tenant application that makes it safe to test in production. So that is the power of the operational notebook. So that's what I wanted to go over today. Those are a couple of advanced modeling techniques. You can compose models together by importing different models. You can create these operational runbooks. You can set up configuration and load that configuration right inside of your notebook. So all of these steps are going to be documented on Jinaga.com or on Jinaga.net, since we're using .net for these runbooks. And you'll see examples. These example runbooks are going to be in the Festify repository, which is on my personal GitHub repository, Michael L. Perry /Festify. I'll also make versions of these available in the Jinaga repository, and I'll put them on Jinaga.net, so you'll have access to them anywhere you happen to be looking for them. So yeah, I'm really excited. The new book is out. I'm also really excited that the replicator as a service is almost ready for Azure. I'll have to figure out why it's not running this morning and make sure that doesn't happen when it goes live. But I'm right in the middle of using operational notebooks in order to set up the environment in Azure. So all of this is ongoing, and I'm going to share those steps with you as they occur. So come on back next week at this same time. Join me on Discord or on YouTube. And I believe that next time we are going to be diving into using the patterns of CRDTs in order to solve a difficult problem with virtual machines and VHDs. So come on back and let's explore that together. Thank you so much.